Hello everyone, my name is Taís Rodrigues. I am a PhD student at University of Campinas, and I would like to thank you for the opportunity to show our work. So, new psychoactive substances are drugs of abuse that are not controlled by the single conventional narcotic drugs or conventional psychoactive substance, but that may pose as a public health threat. New does not necessarily refer to new inventions, but drugs that recently become available on the market. They have similar effects as substances under international control, but they are more potent. They have a wide and diverse range of chemical structures and unpredictable pharmacodynamics and pharmacokinetics and intestinal effects. According to World Drug Report from past year, more than 500 NPS were on the market in 2019, being 71 newly identified in that year, and more than 200 were not reported since 2016. They can be classified in 9 different groups. And according to UNODC World Warning Advisory, up to December of 2020, more than 1,000 synthetic NPS were reported, being stimulants and synthetic cannabinoids the major groups. Synthetic cannabinoids are also known as K2, K4, or SPICE. They are synthetic cannabinoid receptor agonists interacting with CB1 and CB2 receptors. And in vitro studies show that they have a higher affinity for these receptors than the THC. They can also cause upregulation of serotonin receptors, especially in the hippocampus and prefrontal cortex, that are regions of the brain that are linked to drug addiction. The symptoms presented by the user can be increased heart rate, leading to a heart attack or stroke, gastrointestinal, kidney, and respiratory problems, agitation and irritability, confusion, hallucinations, delusions, and psychosis, and also seizures. So they are cyclopyrite compounds, and they also vary widely in their potency and efficacy. And here I show the structure of the THC and the classical cannabinoid, and we can see the image of the structures, and I'm showing the difference between the two structures. We also have the non-classical cannabinoids that are called the CP compounds that were synthesized by Pfizer in the 80s to be used as analgesics, but they became drug of abuse. And we also have the amino killing-dose. Recently, we have a higher structural diversity. I will talk about the indazole carboxamides and indole carboxamides that were the major group that we saw in this work. And the major difference between these groups are the presence of this nitrogen. So World Drug Report also shows the prevalence of synthetic cannabinoids in global quantities of NPS seizures in between 2009 and 2019, and also the prevalence of this group and NPS identified member states. The report issued by the Federal Police in 2018 of Brazil showed that of the more than 9,000 reports, 43 has had NPS and 16 were newly identified, including 5-FMDMB-PICA, that is a synthetic cannabinoid. And until 2017, we saw the class of NPS more in herbal mixtures or pill, but since that year, we saw them in blotter paper and powder. They observed a decrease of seizures of synthetic cannabinoids between 2016 and 2018. They believe that's due to the implementation of legal response. So synthetic cannabinoids and 10 generic structures were placed under control. Here I show the structure 9 of these 10 generic structures and the similarity with 5-FMDMB-PICA. So the aim of this work was to describe the identification of synthetic cannabinoids in 56 infused paper sheet samples seized in Brazilian prisons between 2016 and 2020, especially because some papers talked about alignment between synthetic cannabinoids detected in prisons and the local market. Infused paper sheet samples seized by the São Paulo State Police or Brazilian Federal Police were analyzed by the CMS, LC-MS, FTR, ATR, or NMR. Of the 56 samples, we saw a prevalence of 5-FMDMB-PICA and MDMB for NPNACA. And when we saw other data from other countries, we see the prevalence of the synthetic cannabinoids. So UNC Tox portal showed the prevalence of 5-FMDMB pica between 2017 and 2020. And in 2020, we already saw MDMB for NPNACA, especially in the US. European data showed that drug season between 2019 and 2020 had the prevalence of MDMB for NPNACA. These drugs were seized in prison and correctional houses from 6 different countries. And another paper showed that seizure data from gay and the analysis of unit samples from general prisons show the prevalence of MDMB for NPNACA. And an American paper showed that between March and July of 2019, the analysis of unit samples from Pennsylvania prisoners showed the prevalence of 5-FMDMB pica. In our work, we saw the prevalence of indazole tricarboxamides, indole tricarboxamides, especially F5-FMDMB pica and MDMB for NPNACA. And in some samples, we saw more than one synthetic cannabinoids, such as 5-FMDMB pica with 4-FMDMB pinaca or MDMB for NPNACA. And in one sample, we saw the mixture of NPS, such as ADB for pinaca and NPO. So in this figure, I showed two samples that contain 5-FMDMB pica. And in this one, MDMB for pinaca, I don't know if you can see, but there are some crystals in the paper sheet sample. And we saw also these LSD-like blotter papers that contain MB for pinaca. In conclusion, we believe that the close monitoring of the seizures could lead to early warning for law enforcement, especially because of this alignment between prison and local market. In Europe and US, we saw the increased smuggling of infused papers containing synthetic cannabinoids in prisons. In Brazil, between 2019 and 2020, we saw also this increase. In Europe and US, also in Brazil, we saw the prevalence of indazole tricarboxamides and indole tricarboxamides derivatives. And we believe that this data could help to determine safety, security, and health risk leading to positive effects in prisoner staffs and their prison environment. To the best of our knowledge, this was the first demonstration of synthetic cannabinoid smuggling into prisons in Latin America. This data was already published last year. And I would like to thank you to Inspect Project and its funding agencies. Thank you very much for your attention.